Hi, welcome back. This is a mensuration question here. We have a sphere immersed inside a cube. So let's read the question. The diagram shows a solid sphere with radius 6 centimeter inside a cube with side length 20 centimeter. The cube contains water to a depth of 15 centimeter. The sphere is removed. Calculate the new depth of water in the cube. The volume of sphere is already given there, 4 by 3 pi r cube. It's the formula. Now, what's happening here? We have a sphere kept inside the tank, and the tank is in the form of a cube. Cube means all the length, width, and height is going to be the same. So it's a cube of 20 centimeter. That means the length of the cube here, this will be 20. The width also will be 20, but the height, it is not completely filled. That is why the height is 15. So length is 20, width is 20, and the height is 15. Now what is happening here? When we remove this sphere from the tank, the length and the width is not going to change, but the height is going to decrease. The height is going to be reduced. Let's say it decreased this much here. Let's say that it decreased till here. Now let's consider this height. Let's take it as x. Let's take it as x over there. Now I repeat, here we have a sphere. So we are removing that sphere. When we remove that sphere from the tank, the water level, the length and the width is not going to change. It's only the height is going to decrease. So that change in height, I'm just taking it as x here. Now, what we have to do here is that we need to find out the volume of sphere, and then we equate it with that particular. This shape is also a cuboid. This shape is also this volume. This volume is actually a cuboid with length 20, width 20, and height x. So when we remove that sphere, that is the decrease, that is the height that is getting decreased. Length and width is just remaining the same. The volume of sphere will be the same as the volume of water that is being decreased, or volume of water, yeah, that is being decreased from the tank. So first let me find out the volume of sphere here. Volume of sphere is 4 by 3 pi r cube. So this is 4 by 3 into pi, we know it is 3.142 into r cube. Radius is mentioned here, the radius of sphere 6 centimeter. So 6 cube. When we put this in calculator, 4 into 3.4 into 3.142 into 6 cube will give me 2714.688. Whole thing divided by 3. I'll get it as 904.896. Approximately, I'll take it as 905. So I'll get the volume of sphere as 905 centimeter cube. Now, when we remove this sphere, this same volume is being decreased from the tank. So here, the volume of this water here, I can find out. It's a cube. Basically, it's a cube. Volume of a cube or a cuboid is length into width into height. For a cube, all length, width, and height is going to be the same. So I'm going to find out length will be 20. Width will be again 20. Width is also 20. They both are not going to change. And the height is x. So that is 20 into 20, 400. 400x. These two values are the same. 400x and 905, they are the same, because I told you the volume of the sphere will be the same as the volume of the water that is being reduced. So volume of the sphere is 905, and the volume of water that is being reduced here, it's in the form of a cuboid. So 20, 20, and x. So 400x. So when we find out the value of x, 400 goes to the other side, it becomes division. So 905 over 400, So 905 over 400 will give me 2.2625. So x will be 2.2625. That is not the final answer. What we need is the new depth of water in the cube. So new depth will be from 15, subtract this x value, that is 2.2625. 2.2625. So 15 minus 2.2625 is 12.74. 12.74 centimeter will be the new height when the sphere is getting removed. So one thing you need to understand, only one thing that you need to understand from this question is that when a sphere is removed from the tank, the volume of the sphere will be equal to the volume of the water that is being decreased. So I hope you understood this question. If you have any doubt, please feel free to write it in the comment box. Thank you for watching.